Hey everyone, so we're going to switch gears a little bit and start talking about simplifying radicals. So we sort of already did this before when we are doing the quadratic formula, where if you have a radical that's not a perfect square, so can't be simplified to be a whole number like 16, you could take the square root of that and get 4, or 25, take the square root of that and you get 5. Um, then you have to rewrite it so that you can get some of it out of the radical. So for example, here, if we had something like radical 240, what we would do is divide it by all um, the perfect squares leading up to 240. So 4, 9, 16, 25, and try to find out what the biggest one is that divides into this, and then we would rewrite it as a product of the two numbers. So 240, the biggest perfect square that goes into that is 16. So 15 times 16 equals 240. So you can rewrite it as that. Take the square root of 16 and you get 4. So radical 240 can be simplified as 4 radical 15. Now what we're going to do is do pretty much the same thing, but now deal with it with variables. So this is how we're going to change it a little bit. And we're going to do a lot more with the radical. So let's say we had an example like this, x to the seventh. Now the thing is, this is not considered a perfect square because the power, the exponent, is an odd number. We can only take the square root of variables when their exponent is an even number. So what we're going to do instead is, just like we did before, rewrite this so that it is the product of a perfect square or something with an even exponent, and then whatever's left over, the other product. The nice thing about this is that the largest variable that goes into x to the seventh, that's a perfect square, will be one less of this. Because remember, we're looking at even numbers. So the way this would be rewritten as x to the sixth times x. Because remember, when you have two numbers and you multiply them, you add their exponents. So 6 plus 1 equals 7. So square root of x to the seventh can be rewritten as square root of x to the sixth times x. Now we have something that we can actually take the square root of. Remember, when it comes to exponents, when we take the square root, we're just halving that number. So x to the sixth becomes x cubed when we pull it out of the radical, and we now have x cubed times radical x. So that's what we're going to do in this. We're going to start with a few practice problems of just doing the radicals on these variables. Then we're going to look at combinations of numbers and variables. All right, so here's the first set. Pause the video work itself and we'll go over in a second. All right, so A is really easy. We don't even have to do much work. Taking the square root of x squared, because that's an even number, it just becomes x. Same thing with B, again, because the 4 is an even number. When we take the square root, we half it, and we end up getting x squared. Now, C is where it gets a little bit different, where now we have to rewrite this. So this can be rewritten as x squared times x, because 2 plus 1 is 3. And that means when we take the square root of this, the square root of x squared is x, and we get x rad x, because that remainder x is still left under the exponent. Same thing with x to the fifth. This can be rewritten as x to the fourth times x. And just like we saw in B, this can be rewritten as x squared. So it'll just be x squared times radical x. For the most part, when you do these simplified, whatever the variable is, there's always going to, if you started with an odd number exponent, there's always going to be one extra being left in the radical. E, the y squared is pretty straightforward. That's an even exponent, so that just becomes a y. The x to the seventh, that's going to be rewritten as x to the sixth times x. So when we take the square root of this, half that exponent. So what we're going to have outside the exponent is y and an x to the third. And then all that's going to be left is single x under that radical. So this would be the simplified. Y outside the radical, because that's half of 2. Y cubed, x cubed, because that's half of x is 6. And that's pretty much it. Here's the next step. Pause the video on itself, and we'll go over in a second. All right, so here, same thing we did before. We're going to rewrite the 54 as a product of two numbers, one of which has to be a perfect square. The two variables, x and y, both have even exponents, so I'm going to ignore them, and I'm just going to worry about the 54. So 54 can be rewritten as 9 times 6, 9 being the largest perfect square. And then I'm just going to square root all these perfect squares. 9 square root becomes a 3, x to the fourth square root becomes x squared, and y to the sixth square root becomes x cubed. So this ends up being 3x squared y cubed times radical 6. So the 6 remains in the exponent because it's not a perfect square and there's no other perfect squares that go into it. All right. Now this one's a little bit different because we actually have something outside the radical. So we have to kind of keep that in mind. But we're going to do the same thing. The 12 is going to be rewritten as a product of two numbers. In this case, it's going to be 4 and 3 because those are the perfect square being 4. Y is going to be rewritten as y to the fifth, y to the fourth times y. So we end up having this. So my perfect squares are 4, x to the eighth, and y to the fourth. So square root of 4 is 2. Square root of x to the eighth is x to the fourth. And square root of y to the fourth is y squared. So I'm going to be left with this. The 3 and the y remain under the exponent. Now, what I said before is that I'm going to need to make sure I keep track of the 7. This gets multiplied by the 2 that I got from taking the square root of the 4. So I had to do 7 times 2 now, and I get 14. So my complete simplified expression is this. 14 x to the fourth y squared square root 3 times y. All right. Here's the next question. Pause the video works up, and we'll go over in a second. All right, so what we're going to do is same thing before, the 27. So 27 is divisible by 9. So 9 and 3 would be the factors to replace 27. And then x cubed, I'm just going to write it as x squared times x. Again, we're just taking one away from this to split it up. So 9 and x squared are my perfect squares. Square root of 9 is 3. Square root of x squared is x. So we're left with 3x outside the radical and a 3x inside the radical. Going back to here, so my number is 28. The largest number that's a perfect square that goes into that is 4. So the product would be 4 and 7. I don't do anything to the x to the fourth since it has that even exponent, but y to the seventh I'm going to replace as y to the sixth times y. So my perfect squares are 4, x to the fourth, and y to the sixth. So underneath the radical, I'm going to keep the 7 and the y, and outside it's going to be a 2, x squared, y cubed. All right, and here's the last question. Pause the video, work itself, and we'll go over a second. All right, so same thing, make sure that we keep track of this negative. So the 200, the two products, factors that go into that would be 2 and 100, 100 being the largest exponent. And then the b to the ninth is going to be replaced with b to the eighth times b. So 100, a to the fourth, b to the eighth. Those are my perfect squares. This is 10, a squared, and b to the fourth. And what I'm left underneath the radical is 2b. So my final answer becomes negative 10, a squared, b to the fourth, radical 2b. For number 6, same thing. I'm going to rewrite 96 as 6 times 16. And then do m to the fourth times m to replace this number, or this variable. 16 and m to the fourth are my perfect squares. And the 16 square root is 4. M to the fourth square root is m squared. So I have negative 1/2 times this 4m squared radical 6m. 4 times a half is 2, so it simplifies to this. And that's pretty much it with these problems. You take it one step at a time. The numbers can get a little tricky sometimes. What I always recommend is plug it into the calculator. Um, going over to here, you can do 1 half of radical 96. See what you get there. When I plug it into my calculator, I get 4.899. And then what I would do is go over to this and do 2 radical 6. I'm ignoring the variables right now and see what I get there. And I get the exact same number, 4.899. So this kind of can be done as a way of checking to make sure that your numbers are on the right track. All right, we'll continue talking about stuff with radicals, so make sure that you go over this. If you have any questions, let me know. Complete the rest of the questions in the packet. If you have any follow-up questions, please make sure that you let me know. Send me a message on mine. Otherwise, I'll see you later. Good luck and have a great day.